Hi, I hope everyone is doing great. Pointers tend to be a difficult and confusing subject for beginners in C programming. Perhaps that's why a lot of other people don't even cover them at all in their lessons. The good news is pointers don't have to be difficult or confusing. Admittedly, even the Arduino reference doesn't have a lot to say about pointers and does explain that they can be tough for new programmers to learn. But it also admits that though it is possible to write many Arduino sketches without using pointers, they're great for manipulating certain data structures. It also goes on to say that the use of pointers can simplify the code, and knowledge of manipulating pointers is handy to have in one's toolkit. Toward that end, this will be an introductory lesson on pointers. So what do we mean by pointer? What is a pointer anyway? When we say pointer, we're not referring to a type of dog. We're not talking about one of your fingers, and we're not talking about a rude or aggressive person. Pointer in C is a variable whose value is a memory address. Pointers indirectly refer to, or point to, other variables or part of their contents. While a variable normally contains a specific value, a pointer contains the address of a variable that contains a specific value. So, what does that mean? Let's start with an analogy most of us are familiar with. You most likely have an address. Some of you live in a house, others an apartment, or maybe a condo. So the building you live in, regardless of what it is the variable in this example. We're just going to assume it's a house from here on. Your house has a specific location, and you can be found inside your home, assuming you're there, of course. So in this example, you're the value, the house is the variable that contains you, and the address is, well, the address. If someone wants to find you specifically, they'll most likely look for you at home. To do that, they need your address. So your address gives the location of your house, which is the variable in this case, which contains you. And remember, you're the value the variable stores. Therefore, your address indirectly references you. And if whoever is looking for you wants to know what you look like, all they need to do is knock on the door or maybe peek in the window or something. Let's put this in terms of computers. While variables directly reference a value like count, in this picture directly references 7, pointers indirectly reference a variable by pointing to the address of a variable, like countPTR points to the variable count, which contains the value 7. All this is nice, but why use pointers? Because the hardware instructions of computers and microcontrollers rely heavily on addresses. Pointers enable you to express yourself in a way that is close to how the machine expresses itself. This makes programs with pointers efficient. Pointers also offer an efficient way to deal with arrays. In fact, arrays are simply pointers in disguise. Let's talk about pointers in your programs. Like other variables, you must declare a pointer before using it. For example, the declaration here declares the variable pointing to be of type int. You could read the declaration to say, pointing is a pointer to an integer. The variable number is just a standard integer, not a pointer to an integer. The asterisk in the declaration applies only to pointing. Each variable you want to declare as a pointer needs to be preceded by an asterisk. So if I want to declare 2 pointers, I need to do something like this. The asterisk is known as the indirection operator, or the dereferencing operator. The type specification, in other words a type of variable, which is an integer in this case, identifies a type of variable the pointer points to, and the star or asterisk identifies a variable itself as a pointer. It's not enough to say that a variable is a pointer. You need to tell the compiler what kind of variable the pointer points to. One last note on declaring pointers. You can use pointers to reference or point to floats, longs, chars, and a host of other data types, not just integers. Before we venture deeper into the thickets of pointer forest, a few words on the address operator are in order here. In many languages, the address of any given variable is a computer's business, and a programmer doesn't get that information. However, in C and Arduino, you can access the address of a variable using the address operator, which is just an ampersand. When followed by a variable name, the address operator gives the address of that variable. For example, ampersand my house gives the memory address of the variable my house. Suppose we declare a pointer with the name PTR. We could write a statement like this. We could say that PTR points to my house. However, the actual value of PTR is the memory address in hexadecimal of the variable my house. Let's say my house is an integer whose value is 1, 2, 3, 4. If we use the indirection operator, we could dereference pointer PTR this way. Okay, So I know this is new to a lot of you, and you may be confused about all this pointer stuff. Enough theory. Let's go over to the Arduino IDE and write a simple program using pointers to demonstrate this. Okay everybody, here we are in the Arduino IDE, and we've had enough theory, so let's roll up our sleeves, dive in, and write some code and upload it to our board to demonstrate pointers. And what I want to do this time is I want to demonstrate pointers by swapping the values of two variables. Okay, little comment there, so we know what the program does. Remember, commenting is good practice. And here we have setup and loop already open for us. The Arduino IDE pre-populates this. So let's go into setup and let's think about what we need to do. So first of all, in order to verify that anything's been swapped at all, we need some kind of communication or some kind of printout to show up on the screen. So we're going to probably use the serial.print function. In order to use the serial monitor and have it output anything, we need to initialize it. So you guys know this already. We're going to go ahead and do a serial.begin, 9600 baud rate, pretty standard. And in order to actually do the swap, we're going to try to write our own function. Now, we have talked about functions before in the past, but we haven't talked about writing them or creating our own functions. This one's going to be real simple. In the future, we'll go into more detail about creating functions, but right now we're just going to kind of do it, and hopefully you'll get an idea of how this works before we go into more detail about it. It's not going to be very complicated, but we need what's called a function prototype. So I'm going to put a function prototype here, and we're just going to call our function swapper. And, oops, I don't want to do that. We're going to call it swapper.